You've seen how to add, subtract, multiply, and divide integers. You've also seen how to simplify expressions with integers. In this video, we look at using integers to graph points on the Cartesian coordinate plane. Let's start with an example. A construction truck goes from building A to building B to building C. Describe the coordinates of these buildings. Notice the Cartesian coordinate system. Here is the y-axis, and here is the x-axis. This happens to just show quadrant 1. This truck goes from point A here to point B here to point C here. These 3 points can be graphed with integer coordinates. Here is a version of the graph with just the points. Where the x and y axes intersect is the origin, which has coordinates 0, 0. Let's assume that each tick mark along the horizontal and vertical axes represent 1 unit. Let's look at point A. We start at the origin and count 1 unit along the x-axis until we are aligned with A. Now we move up 2 units to get to the point. So point A has coordinates 1, 2. This number is the x-coordinate, and this number is the y-coordinate. Now let's look at point B. Start at the origin and count the number of tick marks along the x-axis to align with B. There are 1, 2, 3, 4, 5, 6, 7, 8 units. And we move up 2 units. So point B has coordinates 8, 2. Now let's move on to point C. First thing, notice that it is vertically aligned with point B, which we know has an x-coordinate of 8. There are 1, 2, 3, 4, 5 tick marks. So C has coordinates 8, 5. Let's look at another example. A diver takes a dive, and his path is shown in the red dotted line. He passes through points A, B, and C. What are the coordinates of these points? We can use positive and negative integers to show the coordinates of the diver at the 3 points. Here is a clean version to make it easier to identify the coordinates. Recall that where the x and y axes intersect is the origin, which has coordinates 0, 0. This coordinate system shows quadrant 1 here and quadrant 2 here. Quadrant 1 has all positive coordinates. Quadrant 2 has positive x and negative y coordinates. Let's assume that each tick mark along the horizontal and vertical axes represent 1 unit. Let's look at point A. We start at the origin and count 1 unit along the x-axis until we are aligned with A. There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 units. Now we move up 1, 2, 3, 4 units to get to the point. So point A has coordinates 10, 4. Now let's look at point B. Notice that the point is on the x-axis. Any point on the x-axis has 0 as a y-coordinate, so we just need to find the x-coordinate. Start at the origin and count 1 unit along the x-axis until we are aligned with B. There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 units. So point B has coordinates 15, 0. Now let's move on to point C. First thing, notice that it is just 1 unit to the right of point B. Since point B has an x-coordinate of 15, then C has an x-coordinate of 16. Now we count down 1, 2, 3, 4 units along the y-axis.
4 units below the x-axis makes the y-coordinate -4.
So point C has coordinates 16, -4. Let's look at a final example. Find the coordinates of points A, B, C, and D, which are the corners of a rectangle. Notice that this rectangle is centered at the origin. What this means is that the y-axis splits the rectangle into equal sections. The same thing happens with the x-axis. It splits the rectangle into 2 equal sections this way. This means that the rectangle is symmetric about the x-axis and the y-axis. Now we can look at the coordinates for the 4 points to see how this symmetry is reflected in the coordinates. Notice that positive and -7 and 3 are integers that make up these coordinates. Look at any collinear pair of coordinates, and you'll see that pairs of coordinates are opposites. For example, A and B have opposite x coordinates, while D and C also have opposite x coordinates. AD and BC have opposite y coordinates.